Today we will go to discuss about our usage of daily life in plumbing sector. So this is the equipment for which will be used for pipe building section. In that pipe building section, there will be two types of pipe building sections are there. One is we are using our normalized straight pipes, which can be used or we can modify it into our utilized phases. And another one of pipe building machine, it will be for the circular pipe building machine. Now we will connect these pipe building machines to in that subject of heat transfer phenomena. So basically, we know that heat transfer phenomena in solid surfaces is conduction. In this pipe bending equipment, I will connect it with the solid surfaces of conduction equation. So we know about that solid means that is an higher region of temperature is traveled into the lower median of the temperature. That is in the conduction of the solid medium. So in this pipe bending equipment, this is the component. It will be this is the located part of the pipe bending connection section, and this uh, connections are indicated as the tightening section or adjustment section of the pipe bending machine. So now we will back to this heat transfer phenomena. In every examples of fluid surfaces into the solid surfaces, that is concurrent to the heat conduction of phenomena. So in this pipe bending equipment, the heat transfer phenomena is the liquid, any type of liquids or it's traveled into the position of conduction pipe. So the normalized section of this heat transfer is localized or transformed or concurring with the equation of heat conduction equation. Basically, we know about that heating conduction equation is the heat transfer phenomena is respect to the area measured is a negative portion of the heat conduction equation with respect to the temperature gradient is a Td by dx. So in that particular area, the area is a negative direction and it will be maintained or and it will be positively to the heat law of cooling convection equation. Basically, the convection of heat cooling is HA is a del T. The del T is a differentiation of surface temperature to the modified of wall temperature. So this heat transfer phenomena of convection part is travelized or differentiated with the dimensionless section areas. And the dimensional areas are, we are know that the dimensional numbers of Reynolds number, Prandtl number, Stanton number, and cross number, and another one final one is it is indicated to the viscous force. And basically the dimensionless numbers of first one is Reynolds number. This is the ratio of inertia force to viscous force, and this Reynolds number basically it is categorized upon the flow direction with respect to the Reynolds value. It is the laminar to turbulent value. For that laminar flow equation, the value of Reynolds number is 0 to 20,000. In between the laminar flow values, the flow is subsequently in a smooth and continuous path. And for alternate this, the fluid particle or fluid path, it will be the zigzag condition. So that the flow is and the flow parameter is called as turbulent flow. For that turbulent flow period, the value of Reynolds number is beyond the 20,000. In example of our real-time example, if we are considering a sink in our daily usage of our home kitchen or something else in our house, the flow direction of water from that pipe, it will be before that reaches the sink, it will be the flow path, it called as laminar flow. After the fluid particle, it will reaches or it will be fall down into the sink, the fluid particle it will be reflected or removes. So that is the flow path. It is called as a turbulent flow. In the turbulent flow, the zigzag values are these. Already we said that dimensionless values are considered in the particular part. So this is the pipe bending phenomena of heat transfer section. with real life example of which is connected to the heat transfer life problem, and basically it is focused on conduction and convection application.